everyone, this is Jayanthi Thalapathi from Gateway the Complete School. So here today we are going to see the past paper questions about the elements, element, atom, compounds. So regarding that, even the periodic table. So all these come under this type of question actually. So here it is used as a fuel in nuclear reactor. So which will use in nuclear reactor? Actually we all know uranium we are using in nuclear reactors. So uranium 235, uranium 238 we are using, that we all know, and uranium, polonium, all these we are using. So uranium itself enough for this question actually. And it is the only non-metal which is a good conductor of electricity. We all know the carbon, in a graphite allotrope will conduct electricity because of the delocalized electron. So graphite has delocalized electron. Actually when you see graphite structure, it will be like this. So in this case, if you take one carbon atom has 4 electrons. So one it is shared with this, and the other one with this, and the other one with this, and the 4th electron will that shows as extra electron. So that is delocalized in the structure. So that is why the graphite conducts electricity. So you can write graphite, but it's allotrope of carbon. So you can write carbon too. And inert electrodes are made from this metal. So metal like platinum we are using for electrodes. So we are taking it as an inert electrode. Though it is a metal, we are using even titanium. All we are using it as an inert electrode actually. So we can write this. Even the electrolysis chapter you can see this. And this gaseous element is used to fill balloons in preference to hydrogen. So we know hydrogen balloons and helium balloons are there. So helium is the answer for this because helium will not react with anything. So this is very lighter than the other gases. So this will fly. So we are filling helium in the balloons. And an element which can form an ion of a type X3 minus. 3 minus means you have to take the 5th group elements, all the 5th group elements. You can take nitrogen or phosphorus. So this is 5th group element actually. So anything you can write, nitrogen, phosphorus, anything you can write, any 5th group element you can write, because if you take nitrogen has 5 electrons in its outermost shell. This needs 3 more to become octet. So it accepts 3 electrons, that is why X3 minus. So N3 minus for this. And it has the same electron distribution as a calcium ion Ca2 plus. So if you see when any element donates or accepts electrons, it attains the electronic configuration of noble gas elements. So when calcium's electronic configuration is 2882. So it has 20 protons. So this is electronic structure. Actually if you take calcium 2 plus, that means 2 electron when it donates. So 288. So here if you take in the periodic table group 8, group 8 or 0 group element, here 18, argon 18, that shows 288 is argon's electronic configuration. So in that case you can write argon. And also one more thing is potassium. If you take potassium has 19 electrons. So if you take this 2881, so the potassium ion, if you write potassium ion, that is also correct because that also has 288 electronic structure. And if you we'll move on to the next question. The element is in period 5 and group 6. So if you take period 5, this is 1 actually, 2, 3, 4, 5. So this is period 5 and period 5 and group 6. So group 6 is this. So period 5 and group 6 gives tellurium. So the answer is tellurium. This is easy to find out actually. If you know the number of groups and periods, you can easily find out the element and easily you can get 1 mark. So one set of questions will come like this from this chapter. I mean, like it covers the periodic table and also the atomic structure. And here the one more type is the table. They might give table like this. So here you can see particles A, B, C and the number of proton, electron and neutrons are all given here. So here what is evidence in the table for each of the following? So the question is particle A is an atom. So what is the evidence? So A is an atom, I mean it has an electron 15 and proton 15 protons. So protons are equal to electron and neutron 16. Fine. So if you see which has 15 protons and electrons 15 and the neutrons, here if you calculate the mass number is 31 minus 15 is 16. So in that case number of neutron is 16. So this shows phosphorus. So according to the periodic table you can explain this in the given lines. And they are all particles of same element. How do you know these are all particles of same element? Because they all have 15 proton number. So this shows all are under same, all are same element, all are phosphorus. So these are isotopes of phosphorus. And particle B is a negative ion. If you take particle B, number of proton 15 but number of electron 18. So this accepts 3 more electrons to become octet. So when it gains 3 electrons, obviously this is negative ion. 3 minus actually. So and that is why it is negative ion. And particles A and C are isotopes. So A and C, what is isotope actually? Same number, same proton number but different number of neutrons actually. So that is isotope. So if you see here A and C 15 proton number and the neutron number is 16 for A and 17 for C. So that you can explain over here. And what is the electronic structure of particle A? Particle A contains, electronic structure, about electrons only you can write. So A has 15. So electronic structure is 2 in the first shell, 8 in the next shell and 10 and 5 more in the third shell. So what is the valency of the element? Valency, it has 5 electrons, so it accepts 3 more to become octet. So in that case the valency is 3 minus. And is the element a metal or a non-metal? Give a reason for your choice. So phosphorus it is under P block elements. So P block, all the P block elements are non-metal. So it is a non-metal because of it is under P block elements. And that too in the fifth group all the elements are non-metals and phosphorus does not conduct heat and does not conduct electricity too. Yeah, thank you so much children. So these type of questions we will see in the next videos also. Until then, bye bye.